How's it going, everyone? Emiliano Gonzalez here, and in today's we're going to talk about is the async nature of JavaScript. So this is a course that is taught by Will Sentence, the CEO of CodeSmith, this software engineering and machine learning engineering residency, headquarters in London, New York, and California, where the goal and the business model of that company is that it will take people from those boot camps, which is something that is good as a way to show is some basic levels of knowledge, and it's kind of accelerating to a senior roles. So why we're looking today at this? So what is the goal from this course, and then the goal of this series of videos? First is that we're going to see now this new ES6 and ES7 features. Since this now introduces a new way of how can we deal this asynchronicity in JavaScript. So how that plays out in JavaScript, also how we're going to see this new way of thinking, how can we access to data in a collections through objects or through iterators. We're also going to see is how can we now control the data flow through generators. Perhaps that thing doesn't ring any bells right now, or doesn't sound, it's quite abstract, okay? But we're gonna see that how all of this combine so to make sense with the async and await. So now we can have is a more precise knowledge and understanding about how this is working behind the scenes. And that's the entire reason of this goal. So in today's video, we're gonna make a quick recap of the core section and the thing that I have learned so far, as well as with the new topic, which is iterators. So far so good, right? Because first we saw is how now these companies, and especially as a senior software engineer, that how important is your analytical skills, how good is your thinking process, and how you can now those abstractions and those how you can make your thinking process meaningful to others. That's actually the role of the senior developers. So can I implement your solutions based on your explanation? And then we're going to see some good part of the best practice as a way to follow as a software engineer, coding practice, soft skills, like you have to be empathetic, you have to also have patience. And lastly is the language itself, and it is a specification. So that's great. Because now, especially as you move on in your career, this is something that a lot of people actually fail to do, and especially in interview, where we require as a company and as you as an individual, both needs to require that whatever you know here or whatever has been your experience, you can now bring that, answer quickly questions, especially hard questions relevant to in this case, the async nature of JavaScript. So when you are in the field, you know what to do and you can provide value to others, not only for your colleague, but also for the company. Since after all, junior or mid-level roles, so they can take a features and implement a solution even though they haven't seen that language or that problem in the past. But the subtle difference with a senior role is that it can take the features, implement it, and then empower the team by making it meaningful to others how he or she implement that solution. That's quite interesting. That's quite compelling, and for both parties, so the company and the individuals. So now that we are here looking at these quick introductions, just as a way to recap our fundamentals. So what are the basic building blocks in JavaScript, the basic features in JavaScript? Well, first, the thread of execution, the global variable environment, the global execution context, as well as the function execution context, the call stack, and the nice little bonus features of JavaScript. Anytime you create a function and return a function, which create a closure, which is a way of how you can store states persistent. It's a way of how you can store it's a way how you can store persistently the outer scope of a function. In other words, from a function, you can have access to the lexical scope, to the variable environment of the outer function, and that can give us is something, some sort of features like memoize or once. Okay, I want you to now run this function only once. So for example, when you have is a game, once one of those players actually won, you can show is, for example, a confetti. So I just want to run this function once, that can be one good example. And the other is memoize as a way to save computational powers. Anytime you have seen a particular input, the first time you are going to calculate and store its value and return it. But if that input was passed again, so instead of computing that, you already have the result stored in a hash map, and then you're going to return that result. So that's something quite interesting. Quite interesting. You can also do that in the context of closures. It allows us to work in a models or thinking in models. So for example, this immediately invoke function expression, which is something that we actually don't do that anymore, but it exists, is some of the capability that this language allows, is a way of how can we modularize that. So we can create a function, we define as a function, and then we, after that, immediately invoke, and we pass the argument, and that function is going to receive. So now with that huge introductions, then we are looking here at how JavaScript actually handles is asynchronicity. How can we now run tests sometimes in the future? How can we defer task, okay, to be run sometimes in the future? So because JavaScript by itself doesn't have any built-in features, it relies on the host environment. In other words, the browser or the server, in the case of Node.js. So those environments expose facade functions such as set timeout, set interval, timers, okay, where now you can pass a reference, and after a couple milliseconds, then I want you to now run this function. So the way how this works is by using these vacay functions, where you're going to pass this function reference, and now behind the scene, this is the way how JavaScript communicate to the outside world, to the browser or node. They handle and process that timer or that timer, okay? And after a couple milliseconds, all right, your function now is ready to be executed. So how is being, or how now the browser or the server knows that this task is ready to be processed by JavaScript? It adds that to something called callback here. Again, this is only for timers, and we're gonna see that. Why is that? So we got callback that is passing through all of this task that you defer in JavaScript is being added to the callback queue. So the event loop, which is part of the JavaScript engine, it say, let me now, and this is also how you can, how the browser or node can communicate to JavaScript through the event loop, okay? And the event loop say, let me take a look at this callback here, okay? But first, I need to look at the call stack, which is that stack that allows us to know at which line of code we are currently at, or if we are actually running something. But in this case is when you add functions, and that is the global execution environment, okay? So let me see if we are actually running something. Are we? Yes. Okay. No. Callback queue. Sit there. And always asking for that. Hey, is the call stack empty? No. Hey, is the call stack empty? No. All of this next tick until it finally realized that, hey, the call stack is empty. All right. Whatever you have on the callback queue, please pass that to, or go to the call stack. So now he's the one who can allow this. So this is now the mechanism of the timers. But what if we, and again, this is something that is quite interesting. This is an interesting approach, the callback approach. Once you understand that, it's pretty predictable. It is predictable, and it is easy to reason about it, right? So one of the problems of this is that it becomes lengthy and verbose, and especially the more a callback depends to another callback, right? You have now this pyramid of doom. So far so good. So how can we solve that, or especially how the JavaScript designers solve that? By come out with this new features in EX 2015 called promise. So they say, all right, now let's make this promise here object, and especially when we want to now process async operations, okay, such as fetch, okay, let's now do this, because a promise will represent is the eventual completion of a success or failure asynchronous operation, okay. We have to do two things here. One, we're going to declare is an object, okay, and this object will contain is a value, unfulfilled and unrejected properties, okay, where it also has the proto, which contains is a reference to the object function constructor promise, and that contains, and that also have a change of the, or in this case, a proto reference to the prototype object function constructor, and that prototype contain is the reference to a null. So with this prototype change, first is how it inherited property and methods from other objects. And second, what is relevant to this is that this value in this unfulfilled property as well as unreject property, they are callbacks that you're going to pass when particularly in this case, when the fetch functions fail or succeed. Okay, so if we updating the value here, so the promise say, hey, since we're going to create first an object, a promise object that will also contain is something, a property called state that can be pending, rejected, or resolve. Okay, so this object function, it will take first these two particular functions called resolve and reject, that now they give you is control of when you want to resolve or reject from these objects. So we also look at how can we make that using callback, which is great. How you can promisify is your callbacks, and also in those cases, in those use cases, you have much more control about which data are going to be handled. And also is how can we defer tasks that are outside of our control. For example, fetch, or from this facade function, fetch in the browser, and recently on the node, and also other functions, other promises, other async operations like read file in node, and those functions will tell us when this operation has been completed or not. So because we don't have control about this, that's one of the reasons why promise create these two front function, or make these two things. First, it create an object on JavaScript, and second, now it talk to the environment for our demo purpose browser with this facade function called fetch, that it receives the URL as well as the methods and some other property relevant to, for example, make a get request to Twitter, Spotify, Stripe, you name it. Okay, and then because you don't have control of when that operation will happen, you will have to wait until that operation is completed. So all of this is being handled by the browser. So once they get the data, okay, from the Twitter, all right, so now they're going to update the value in JavaScript. Okay, how they update the value in JavaScript is something that is not quite relevant, at least for now. Okay, but what is relevant is that when he update the value, okay, when the browser now updates the value on the promise, and after all, a promise is a closure, it means that it will stay there persistently. Okay, then when JavaScript detect that, okay, how this value get updated, now it will trigger, for example, if the status is success, now it's going to get trigger is whatever we have on the unfulfilled callback, which is an array. So we can define there is or one callback or multiple callbacks. We can thinable. That's one of the reasons why we have this thinable thing. Pretty much like a pipeline or like an assembly line, where you get the value and put it. You get the in an assembly line. Let's say you want to make is butter, okay, and in the butter process you have is the huge block of butter that passed through the first stage. Let's say he cut it in several bits, and then the second process, now here's where it split all of this into separate small slice of butters into that machine. The next stage is to grab one and wrap that into some sort of aluminum. So all of this different stage, pretty much that's what we're doing with the thinable, is that the input from a previous stage, or the input from a previous, the result from a previous function will be the input from this new function, and so on and so forth, and that kind of thing. But the reason here is that now that we have is this, so now that the browser knows that this is the value, and we have now a reference of the function that we want to run, because we pass that with our dot then, and the dot then is something that is quite is misrepresentative here, or is misrepresenting it's misrepresenting how what the dot then actually does, because after all, what the dot then, what it's really doing is to attach the callback that you're passing unfulfilled to the object. That's all what it's doing. So you are not running that, not at all. You are just attaching this callback to the promised object. And the question is that once you attach this, when JavaScript know how to run that, okay? And the answer is thanks to another mechanism that we call is microtask. So now this mechanism here, let me see if I have an image here. Exactly. So now this mechanism here, no, what about this? No, okay. So now this mechanism, the microtask queue, the specs called job queue, it say, okay, so this has higher priority than the callback. You can add microtasks as many as you needed, okay? And the event loop will now, again, ask the question, is the event loop is empty? Is not, I'm going to wait until that is empty. If it is, all right, so let me take a look first at the microqueue task, and I'm going to grab all of these tasks and pass to the callback until the microtask is empty, which means that this is a caveat here, because especially if you're working with recursion in your microqueue task, you have to be careful, because you can never execute callback functions in making the microqueue tasks running tasks endlessly. So you don't want to do that. Again, this is by design how the JavaScript or the ECMAScript designers make that happen and make it work to the microtask queue, and say, all right, so promise, okay, will be handled in this microqueue task. And also another important thing is not only promise, my friend, micro task queue. It also specifies how you can make use of the micro task. Because usually here on the task, this is when you can add, for example, add JavaScript program or subprogram is executed. So for example, with script, okay, this is the way how you can add now elements to the callback. Or the task queue. An events fire, adding the events callback function to the task queue. So any events that fire, for example, now when you're interacting with the DOM, okay, another facade function, so pretty much like the timers and the facade function, once you're interacting with that, those callbacks or those events that are being fired are now added to the callback here. Hey, the user move here, or the user, exactly, if you want to listen to those events. So when you listen to a particular event and you add the callback, that is being processed on the callback queue. Because a lot of people here mention about the set timeout, set timeout, set timeout, set timeout, which is a widely common use case. But also on MDN docs, it tells you that, hey, this is great. This is not only works on this is not only works on or for timers, but also for another facade functions like the event. So when you add a callback to an event, and when that event fire, okay, because now you are talking to the browser, to the outside world through this, so now all of these events are being added to the callback queue. The event loop do again what it's doing, do its job, which is, hey, is the call stack empty? Yes. Let me now grab here whatever I got in the callback queue and put it on the call stack. It's like, hey, whatever is who's next in the callback queue? You? All right. To the call stack. And as you mentioned here, is also with set timers. Okay. So far so good. The event loops driving your code handle these tasks one after another in order in which they were in queue. Exactly. So the oldest runnable task in the task queue will be executed during a single iteration of the event loop. After that, micro task will be executed until the micro task queue is empty. The oldest runnable task in the task queue will be executed during a single iteration of the event loop. So on the one single tick, it will now run is the task in the task queue, the oldest runnable task in the task queue. So after that iteration, then micro task will be executed until micro task queue is empty. So that's exactly what it's doing here, is that if I have, for example, something in the event loop, if I have someone set, or a lot of function sets on the micro task queue, I'm gonna pass and handle that all of to the call stack until that micro task is empty. And then I'm going to now evaluate is the callback queue. But the oldest one, put it there. This is one tick. And the next tick I'm going to evaluate is the micro task again until that is empty. And then the callback queue, but the oldest runnable task in the callback queue. Not all of them, the oldest one. And then the browser moves on to the next iteration of the event loops. Exactly. And so after that tick, okay, after the micro task is empty, and then he move on to the callback queue to evaluate the oldest task there. Okay. Now the browser may choose to update re-render. Okay. It has an internal logic there where you say, hey, this things or this callback here or this function that I pass through the call stack, let's go to consider to re-render. And then the browser moves to the next iteration of the event loops. But this is interesting because now even on the browser you have an event loop, and the event loop is by evaluating is the micro task queue first until that is empty, and then it will move on to the next callback, which is the callback queue, and it's going to evaluate it is the oldest runnable task, not all of them, the oldest, and do that again. Okay, and repeat the process. That's quite interesting and compelling. And the reason of talking about this, okay, is that at first the difference between microtasks and tasks seem minor, and they're similar, both made up of JavaScript code which get placed on a queue at run at appropriate time. Exactly. So all of this tasks that I'm passing and just making use of some particular queues. So now the event loop can handle that in appropriate time. However, whereas the event loop runs only the task present on the queue when the iteration begins, one after another, it handles the microtask queue very differently. These are the two key differences. First, each time a task exits, the event loop checks to see if the task is returning control to the JavaScript. That's interesting. Hey, is this task of the micro task queue, one passing to the call stack, is that function is passing control to the JavaScript? If not, it runs all the micro tasks in the micro task queue. Interesting. And by passing control to the JavaScript, it's like, hey, does this function now have, for example, nested function or more operations that needs to be done in JavaScript world? Okay, is actually this function needs to run some multiple statement here. It actually creates its own function execution context. It passing control to JavaScript. It evaluates if it has control to the JavaScript. The microtask queue, then the microtask, if it's not, runs all the microtasks in the microtask queue. But this is doing each time a task exit. Hey, a task exit, are you passing control to the JavaScript? No? Alright. Let me put it now. Let me grab here from the microtask queue, pass to the callback queue. Hey, is this actually take control of JavaScript? No. Next one. If this task actually take control of JavaScript? Yes. Alright. Let me wait until the call stack is empty. Okay. And once that's done, I'm going to ask that again. Second, if a microtask add more microtasks to the queue by calling queue microtask, those newly added microtasks execute before the next task is run, which is you have to be careful here, especially if in your JavaScript code you are adding more microtasks, and the way to do that is by using this micro queue task. This feature is available in web workers. That's interesting. That's quite compelling. That's quite interesting. Yep, totally. Oh my god. This is part of the HTML DOM API, another facade function, which expose on the window or worker interface at the same time prior to control returning to the browser event loop. It's a short function which will run after the current task has completed. It is work and when there is no other code waiting to be run before control of the execution context is returning to the browser event loop. This lets your code run without interfering with any other potentially higher priority code that is pending, but before the browser regains control over the execution context. Potentially, depending on you need to complete. You can learn more about to use microtasks and why you might choose to do so in our microtask guide. The importance of microtasks comes in its availability to perform tasks asynchronously, but in a specific order. Using microtasks in JavaScript with microqueue tasks. So we can perform now asynchronous operations, but now we can control the order. And I think when I'm working for a particular company, the order matters for them vastly, and especially as those events or as those tasks were adding to that. This is now when this is now where you're going to be challenged here. Microtasks are especially useful for libraries and frameworks that need to perform final cleanup or other just before rendering tasks. Okay. Hey, I already rendered this. I want to perform some cleanup things here with higher priority. If this is allowed you to handle async code, you can also use service worker as a way to guarantee every couple seconds if we can now update this application. Hey, are we connected to the server? Are we connected to the server? Are we connected to the server? If it is, okay, now let me actually fetch those resources for you, and then let's go to update that on the fly. So let's go to update our applications on the fly. Okay. That's quite interesting. Before getting far into this, it is important to note again that most developers won't use microtasks much, if at all. There are highly specified features of modern browsers JavaScript developing, allowing you to schedule code to jump in front of other things in the long set of things waiting to happen on the user computer. Abusing this capability will lead to performance problems. Exactly. But the whole point of looking at these microtasks is especially to know when they are run, how that works, and what's doing behind the scenes, especially when you're using that with promise. And especially when you're doing that with promise, which is something that they don't specify here. Something that they don't specify here. They mention that on the fetch fairly quickly, and okay. That arise when sneaking in using promise to create microtasks can be avoided. For instance, when using promise to create microtasks, exception throw by the callback are reported as reject promise rather than being reported as a standard exception. Also, creating and destroying promises takes additional overhead both in terms of time and memory that a function which properly enqueue microtask avoid. Pass the JavaScript functions to call while the context is handling microtasks into the callback into the microtask queue method, which expose the global context as defined by either window or worker interface, depending on the current execution context. Because now window is an okay. Which expose on the global context as defined by it exactly, depending on the global context, which can be window or worker, which is the browser or this another environment, a background task. A background task. Okay. It represents that it's a background task. Basic dedicate worker example. Multiply number 1. Exactly. When that change, I want you to know what do this. So this is a way of how can we handle here async operations. And as you can see on the main, so anytime you detect that, exactly, first and that, if this is a worker, if the worker exists on the global window object, it's going to create now a worker context, where here you're gonna say is this first and second. Okay, you pass it into an array, you're gonna send message to that. On input change, okay, this is what you're gonna run. This is the callback function. So my worker is gonna send a message with the first dot value and the second dot value, and say console log message post to the worker on any change of that, and then my worker here say on message that's going to read that data. Okay, and on message let's going to read that data. So when we detect that event, which is exactly an event, let's going to now read the data. We're gonna get that data from this micro task here. I think that the using is the micro task for that. And it is funny because it's creating a new worker on here, similar to the worker here. It's a message on okay, all right, on message on here, which now you have this global context on the worker. You say okay, when you detect this event called on message, I want you to return is whatever we get, whatever we receive from that. And the result is this console log worker posting message back to main script, post message work result. Exactly, I'm going to send you this data that I receive from that. That's quite interesting because this is a way of how can we defer tasks, or how can we defer tasks? How can we make tests synchronously, especially on the user, which is quite interesting. And when any one of them change, exactly, when any one of them change, I want you to do that for me. God damn it. Web worker basic example. And then you can think now, and then you can scale things pretty quickly by saying, hey, wouldn't it be nice if we using this web worker not only to handle this task when the user change, okay, but also when the network or when something in the cache is outdated, okay, and then we can pass and update that to our application. Why is that? By making it then much more performance by catching data there, and that's when things get complicated, catching things. Mm-hmm. Okay, 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 okay. Good, good. So today we're gonna talk about now is something important, which is called the iterator. So let me now put it this way. So promise, web API, and also Node, but in our particular case we work with a web API. Promise, web APIs, callback, micro task queue, and the event loop allow us to defer task until the work is completed, and then continue running our code line by line in the meantime. So this is what allows us to work. This is what this enables asynchronicity in JavaScript, which is the backbone of modern web applications, letting us building fast non-blocking. Remember that after all, JavaScript is a single thread, so we have to evaluate one after the another. So if we need to run tests, or we need to defer tasks, whether it's in a timer, whether it is from the DOM event, or when we need to fetch data from a server, an animation, reading the local database, all of these async things that happen, all of these side effects, thanks to the promise. Yeah, thanks to promise. Yeah, thanks to promise, web APIs, callbacks, micro queue task, and the event loop is what allows to defer work. Yeah, it's allowed to defer our actions until is what allows to defer our action until the work is done, until the work is complete, until the work is done, and continue running our code line by line. That's what makes this is the asynchronous JavaScript nature that is made of, that is it's the backbone of the modern web application, letting us to build this non-blocking, this fast non-blocking applications. To me, that's quite interesting. That's very, very powerful, very powerful. Given the nature of JavaScript, even though, and I love it, Okay, so here we are. We're going to take a look now at the iterators. Holy moly. Holy moly, bro. All right. Okay. Exactly. But after all, is that so? All of this mechanism that we have learned so far. So, exactly like promise, web APIs. You have fetch or timers. This facade function, the callback, the micro task queue, and the event loop, which is that. Put it here. That's right. It's actually here because this is all of these components is a promise, 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 web APIs, callback, a micro queue task, as well as the event loop, is what allows to give us the actions to defer task until completion and continue running our code line by line. So this asynchronicity in JavaScript is the backbone of modern web application. So for example, if you want to now is while you are navigating to your bank account, be able, for example, to receive money. Someone actually send you some sort of money, right? Something that happened outside of you normal user experience. Let's say you're looking now is to open up a let's say you are now interested in to open a new credit card, right? Or get a new credit card. So while you're doing that, now someone actually send you money, okay? In that async nature, okay, which is makes the core of this asynchronicity in JavaScript, which is the backbone of the modern web application. Another good example is that let's say you are now is navigating through an e-commerce, and then suddenly you receive a notification that say, hey, here is your product, here's where we're tracking to, it is close to your location. It's about 15-20 minutes to your location. This is something powerful. This is something powerful for the user and those who build that, which now it gives them the ability to, well, thanks to all of these components, so the call stack, the promise, the web APIs, the micro queue task, and the event loop, to now defer an actions of a task until completion. Okay, so defer of actions until the work is completed, and continue running our code line by line. So we receive this work. So let's go to defer this task, okay, or let's go to do this task sometime in the future. And all of these components we're gonna take care out of us, all of this mechanism. So while we're still able to run our code line by line, this mental model is something that Dalryle, I think it is. Oh my God, did I lose my mind? Dalryle. Oh my God. The no creator. Ryan Dahl. Ryan Dahl actually made this. Holy moly, bro. Isn't I think Node is not the best system to build a massive web server. Not at all. I will use Go for that, and honestly, that's the reason why I left Node. it was the realization that, oh, actually this is not the best server side system ever. uh, yeah, but again, like JavaScript, bro. It works. It's not the best. It's never been the best. But as soon as it's actually be good enough, that's great. Mm-hmm. Exactly. Mathematical, beautiful mathematical. I like how Ruby made development so much more, and I guess I could express your ideas much. Exactly. Rails was impressive in that it gave this new structure, and probably it wasn't new, but I think Rails popularized the structure of model view controller, and those things combined really was kind of interest to me. To Germany, where people were talking about this new paradigm of model view controller. In Nginx, everything is asynchronous. So when you build a model for it, you have to be very careful to be non-blocking. And yeah, mm-hmm. Yeah, because that's exactly what uh, this new mental model is giving to you. So this is now what this experience of from the ECMAScript engineers, from the ECMAScript designers, is now trying to show and sometimes impose by the specification as a way to this is the model, this is the thinking model of how we think that we should be dealing with async operations in a language that is interpreted. It means that it reads line by line and it executes statements line by line. Okay? So with that, now you can is, for example, is look at very specific use cases. So for example, how you can receive notification in your mobile for, you can see is when someone actually deposit in your bank account, when someone make a deposit in your bank account, or how can you now um, see a notification, for example, when at which current state of your order, uh, what is the current state at what is the current state uh, in your order based on a product that you buy, that you bought on any of these e-commerce places, you know. But the idea here is that you can now receive async information, async relevant data in your applications, and that's one of the things that I really love about the JavaScript. Even though that it's not perfect, you don't need to be perfect. You just need to be good enough to push the boundary. That's all. Even though that, um, uh, that's one of the things that that draw me with. So the web, now I see more power on the web rather than on specific hardware machine language. So for example, C, C++, and that kind of thing, C Sharp, .NET. There's nothing wrong with that. Well, .NET is web, but there is nothing wrong with that. But I think much more useful in power in building things that can be shared across the world. That's what I dedicate to the JavaScript. Anyway, here we are with iterators. Iterators. Okay.
Now we move on to iterators. Okay, iterators. Now we move on to iterators. Okay, iterators. Iterators. I said at the very start that when we run or we write and run code, what we're typically doing is taking data, storing it, and then functionality that we then apply to that data. Even as simple as I have a score for a player and I increase that score. Functionality onto data. We call our live data that's stored in our application our state. That just means the labels and the data, the values currently in our application at that moment. But that kind of masks a small part that's actually pretty significant a lot of the time, which is I have my data, I have my functionality, but often my data is a collection of data. Maybe an array, a list of data, or a set of data, or a map of data, or an object containing a bunch of properties with data. It's rarely a single element. So actually the process of accessing each of our elements from a collection of data is in itself a task. The data's just not there, which we can apply functionality to. We have to go and access that data. And in arrays, we do it using indexes to grab the individual element. We sort of have a static collection of data and go and grab an element, grab it. And actually, that's not a small process in its own right. But it's kind of, and we'll play that out here with a for loop, and we'll discover that actually it's not the most, I think, beautifully designed process. It's not clear that that's the best and necessary. Most of the time, when I'm accessing my data, I know I just want my element, and I want the next element, and I want the next element. I don't really care about how I go about getting those elements. So wouldn't it be amazing if we could rethink collections of data as instead a sort of stream of elements coming towards me that I could call a function, I could run a function that's just going to instantly return me the next element from my stream, my flow of data. So I would run a function, it would return out the next element from my flow. I'd run it, it would return out the next element from my flow. Rethink my data, not as a static collection, I've got to go and manually get each element in order to run functionality on it, but instead flip it and say, my data's there, and I'm actually going to have access to it by running a function which kind of turns on the flow of the next element of my data. And that is a paradigm shift in how we think about applying functionality to our data. No longer is there the intermediate step of getting the elements, manually going into the data collection and grabbing the next element. That's not a small thing. And it's an unnecessary step when most of the time all I want is my next element in order. So why not instead rethink my process as being applying functionality to data as a data being given to me, element by element, from like a sort of flow of that data. Before we see that beautiful new way of thinking about our collections of data and getting them so we can apply functionality to them, or getting them element by element, one by one, before we do that, we're going to see the old version where we have a list of data and we're going to manually go and grab each element.
Exactly.
There's a beautiful new way of thinking about this, using each element one by one. But let's first see, and by the way, it's going to show us just how kind of imperative, procedural, bit by bit, kind of exactly how we're going to do this old-fashioned method is. It gives us really manual, fine-grained control, but at the expense of a clean, readable code. And also at the expense of, I think, a cleaner way for ourselves of thinking of our data as these flows of data, rather than static collections that we go and grab element by element. So let's first just at least see this traditional way, and I think
this is something quite eloquent, totally, on iterators.
It's taking data code, I said at the very start that when we run or we write and run code, what we're typically doing is taking data, storing it, and then functionality that we then apply to that data. Even as simple as
So, based on your summary, okay, which is part of the intro, how you can now make sense of iterators, is this. So as we write programs, okay, we typically define data, store it, store it. Okay. We typically define data, store it, as well as it is functionality. Okay, as well as it is functionality. All right. So as we write programs, we typically define data store. We typically define data, store it, as well as it is functionality to be applied, and apply that. Yeah, and apply that to our data. That's what we have now. This particular model of how can we group in data and function, how can we group in relevant data and its functionality in one single thing, object. Okay. And not only that,
I have a score for a player, and I increase that score functionality onto data.
You know, so I got a user. Okay, I got a user object. Yeah, I got a user object that have a score property. Exactly, user object that have a score property, or that have amount of money, that have amount of money property, and then functionality that apply to that data. Right? So withdraw or deposit. Okay, so withdraw or deposit. Okay, but most of the time we are not dealing is with one single data. We're often dealing is with collections of data, collections of data structures, of objects and arrays and maps and sets and hash.
Call our live data that's stored in our application our state.
So this is what we call in our application as state.
That just means the labels and the data, the values currently in our application at that moment. But that kind of masks a small part that's actually pretty significant a lot of the time, which is I have my data, I have my functionality, but often my data is a collection of data.
But that kind not reveal a relevant nature of working with data. But that kind doesn't reveal that the relevant nature of working with data. And that is working with collections of data. So you have hash or map or set or arrays, hash, maps, sets, arrays. Which is that's when relevant tasks here are we doing.
Maybe an array, a list of data, or a set of data, or a map of data, or an object containing a bunch.
It's a list, object of objects. That makes quite sense. And this is something that's what you need to pay for mentors, as a way to now give you the explanation, especially based on his experience. And the reason why you are doing here is because you want to actually take a look at what they're saying, and then you got it.
Properties with data. It's really a single element. So actually the process of accessing each of our elements from a collection of data is in itself a task. The data is not there, which of data is in itself each of our elements from a collection. So actually the process of access.
So actually the process of accessing accessing data is in a task on in itself. Is not a task on itself. It's a task on it. It's a task in itself.
Accessing each of our elements. So actually the process of accessing each of our elements from a collection of data is in itself a task.
So actually the process of accessing data on each one of those elements is a task in itself. Completely. This is silly. I have experienced that. It's like, how do in the F do I get data from, for example, hash or maps, collections of data? So for example, arrays or hash or linked lists or maps or objects nested inside of another objects. So accessing data in itself is a task. Accessing data on each of those elements is in itself a task. Isn't a better way to do that we don't need to care about how we do that? For example, imperative code, so we can focus is more on what is relevant. That is, they're now especially facing new problems, and they come up with some sort of solution. So we can focus more on what's relevant, which is working with collections of data.
The data is not there, which we can apply functionality to. We have to go and access that data. And in arrays, we do it using indexes to grab the individual element. We sort of have a static collection of data and go and grab an element, And actually, that's not a small process in its own right, but it's kind of, and we'll play that out here with a for loop, and we'll discover that actually it's not the most, I think, beautifully designed process.
Exactly. So right now, this is not so the process, such process is not beautiful. It's not a beautiful design. Yeah. So such process is not a beautiful design of how can we access data and apply to, and how can we access data and apply a functionality. Such a process is not a beautiful design on how we can access data and apply functionality to it. It is much more verbose and imperative about how we do that. Wouldn't be wouldn't be a better way that instead of focusing how can we access to the data, and apply functionality, wouldn't be a better way that instead of focusing how can we access to the data and apply functionality, step by step we can focus on how to do that on large data sets, which is now more relevant in our daily life as a software engineering, as a software engineering. As a software engineering. That's when it comes now to declarative. Because I see what is the value proposition of imperative and declarative. Is that with imperative we say, okay, all of this is how we do that, right? Step by step, how we do all of these kind of things. Sometimes you want to do that, but in the real world, right now, in the industry, instead of focusing on how can we do that, because usually we don't only work with one single state or one single data. We often work with collections of data. So an array or linked lists, stacks, queues, hash, object, nested objects inside of another objects. So wouldn't be better way to actually access the data and then apply some functionality, because at the end of the day, that's exactly what we're doing here most of the time. And to me, that's
That's the best and necessary. Most of the time, when I'm accessing my data, I know I just want my element, and I want the next element, and I want the next element. I don't really care about how I go about getting those elements. So wouldn't it be amazing if we could rethink collections of data as instead a sort of stream of elements coming towards me that I could call a function. I could run a function that's just going to instantly return me the next element from my stream, my flow of data. So I would run a function, it would return out the next element from my
So instead of writing how to retrieve our data one after the another, okay, so instead of writing on how to retrieve our data one after the another, it'll be better to just by running a function, it'll be better just by running a function like this. Exactly. So instead of writing how to retrieve our data one after the another, it'll be better just by running a function. Yes. It'll be better just by running a function that it give me the next element. Run it again, give me the next element. Especially on large data, especially on collection. Something useful, especially in collections of data.
I run it, return the next element of my flow. Rethink my data, not as a static collection that I've got to go and manually get each element in order to run functionality on it, but instead flip it and say, my data's there, and I'm actually going to have access to it by running a function which kind of turns on the flow of the next element of my data. And that is a paradigm shift in how we think about applying functionality to our data. No longer is there the intermediate step of getting the elements.
Exactly. So here's the data.
Manually go. And that is a paradigm shift. My data's there, data, not as a static collection that I've got to go and manually get each element in order to run functionality on it, but instead flip it and say, my flow. Rethink my data, not as a static collection I've got to go and manually get each element in order to run functionality on it, but instead flip it and say, my data's there, and I'm...
Exactly. So, So instead of writing how to retrieve our data one after the another, it'll be just exactly. So instead of writing how to retrieve our data one after another, to apply a functionality, it'll be better just by running. It'll be better just by running a function that give me the next element. Run it again, give me the next element. Something useful, especially in collections. Instead of putting, so instead of manually, because that's exactly what I do. Instead of manually accessing our data, instead of manually accessing our data and apply a functionality to each one of them, wouldn't be better? So it's exactly, we flip it and say, hey, here's the data, okay? Because the process here is manually. Anything that is manual, it will be automated, especially if something that is repetitive. So we flip it and say, hey, here's the data, okay? Here's the data, an array, and give me the next element to apply a transformation.
Actually going to have access to it by running a function which kind of turns on the flow of the next element in order to run functionality on it, but instead flip it and say, my data's there, and I'm actually going to have access to it by running a function which kind of turns on the flow of the next element of my data.
Exactly. So we flip it and say, here's the data, and let me run a function. Okay, so let me run a function that allow me to apply functionality to each element on the stream of data.
And that is a paradigm shift in how we think about applying functionality to our data. No longer is there the intermediate step of getting the elements, manually going into the data collection and grabbing the next element. That's not a small thing.
Okay, and that is exactly, and that is a shift in and that is a shift in thinking, and that is a shift in paradigm.
Functionality to our data. No longer is there the intermediate step of getting the elements, manually going into the data collection and grabbing the next element. That's not a small thing, and it's an unnecessary. No longer is there the intermediate step of getting the element, and that is a paradigm shift.
Okay, and that is a paradigm. Yeah, and that is a paradigm shift on how we think about accessing our data.
In how we think about applying functionality to our data. No longer is there the intermediate step of getting the elements, manually going into the data collection and grabbing the next element. That's not a small thing.
Yeah. Not needing to manually, or not needing to manually accessing to the data and then apply to the and then apply the functionality, and then apply the functionality. Okay, and that's a paradigm shift in how we think about accessing our data. Not needing to manually accessing to the data and then apply the functionality. So not needing to manually access the data and then apply functionality, which is not a easy thing.
And it's an unnecessary step when most of the time all I want is my next element.
And it is not a necessary step, at least not being descriptive about it. And that is not a necessary step, especially if what I want is the next step, is the next data.
In order. So why not instead rethink?
In order. And I think this is something true because a lot of people are actually technicians, are React developers, Vue developers, Angular. No, you have to go to the fundamentals, man. You are somewhere that you are in engineering, and you also need to pay for your mentors as you go there.
Process being applying functionality to data as a data being given to me, element by element, from like a sort of flow of that data. Before we see that beautiful new way of thinking about our collections of data and getting them so we can apply functionality to them, or getting them element by element, one by one, before we do that, we're going to see the old version where we have a list of data and we're going to manually go and grab each element. We're going to discuss a beautiful new way of thinking about this, using each element one by one. But let's first see, and by the way, it's going to show us just how kind of imperative, procedural, bit by bit, kind of exactly how we're going to do this old-fashioned method is. It gives us really manual fine-grained control, but at the expense of a clean, readable code.
Because there is no, so it is. So on the following example, here we can look at how imperative, which is step by step, are we accessing to our data, okay, where you have much more control.
Gives us really manual fine-grained control.
Which give us much more finer, grain control about it, but at the expense of much more finer grain control about it, but at the expense of readability. And that's the issue that a lot of developers has there. Yep, that's an issue on in itself. Okay.
Oh, but at the expense of a clean, readable code, and also at the expense of, I think, a cleaner way for ourselves of thinking of our data as these flows of data, rather than static collections that we go and grab element by element. So let's first just at least see this traditional way, and I think it's going to show us we want a better way. But here's our traditional way, and I'm going to try and diagram this, but part of the point to say is that for loops, diagramming for loops is an odd thing to do. Honestly, when we think about most of our code, we run execution context to run functionality. Our for loops are these funny little things that happen kind of in isolation of our regular way of thinking about code. But there we go. All right, line 1. James, what are we doing?
We're declaring a constant called numbers.
Numbers.
And assigning it a new array containing the values 4, 5, 6.
Excellent, James. Spot on.
4, 5, 6.
Now, here comes my favorite bit, diagramming for loops. All right, here we go. Check this, do this. Okay, you can already see why these are problematic, but check this. So what's the check we're going to do? Is I less than numbers dot length. Okay, is I, which is initiated to 0, less than numbers dot length, which is 3.
Exactly. Check this.
Okay, which is 3. Is this less? It is. And therefore, do this, which is console log numbers at the position I. And then that's our for loop, written up, tried to be written up in a slightly more logical sense than the kind of weird check this, do the code, come back, do this, check this, the weird circular flow of an actual for loop. Okay,
exactly.
So I is less than 3, so we are going to do this. What is numbers at this point, Michelle?
So numbers is the array 4, 5, 6.
Yeah, and what is I at this point?
I is 0.
0. Already? I'm liking to hear the hesitation. That's enough to tell us there might be a nicer way. So position 0 of numbers is...
This number is...
Michelle?
4.
4.
Sorry.
Excellent.
I can tell it as 4.
Next thing to do is I++. We're going to increment I to 1. Is 1 less than 3? Yes, it is. So we come back down here. Now we're getting position 1 of numbers, which is increment I 0. And what is I at this point?
I is 0.
0. Already? I'm liking to hear the hesitation. That's enough to tell us there might be a nicer way. So position 0 of numbers is... Michelle?
4.
4.
Sorry.
Excellent.
I can tell it as 4.
Next thing to do is I++. We're going to increment...
How important are the diagrams, bro? How important are diagrams? This is our initial diagram of how... This is our initial diagram of how can we access... this is our initial diagram of how can we access, or how can we represent this? How can we represent data? How can we represent a for loop? Okay.
That's our for loop, written up, tried to be written up in a slightly more logical. I is E, I++, increment it to 2, 2 less than 3, yes. We come back down here now, I is what, Victor?
6.
So, perfect, thank you. See? Thank you, Victor. I is 2, so numbers position 2 is 6. So we console log 6, I++. 3 is 3 less than 3, no it's not, so we come out of our for loop. Okay, this is the best you can diagram a for loop, I think, honestly, just saying the conditions, and still, we had our, thank goodness Victor made that mistake, thank you ma'am, because that...
And the final evaluation of the for loop. Finder, exactly. You got. All right.
This is a, so busy figuring out how to access that we can't focus on what we want to do. And by the way, we're going to discover, if we rethink our collections of data as flows of data, where we grab element by element, we can dynamically control those flows of data. We can even set those flows, we can set what our next element in our flow of data is going to look like based on things that have happened in previous elements after they've been returned out. Rethinking our collections of data as instead flows of elements we want to grab one by one is going to give us control over what those next elements will be. We'll see that a little bit later on. Really, really cool. But for now, program store data apply functionality to it. There are two parts to applying functionality to collections of data. One, the process of accessing each element, and then two, what we want to do to each element. Iterators, this new way of thinking about accessing data from collections of data, that means like lists or arrays or whatever, automate the accessing of the element. So we can focus on what we do to each element and make it available in a super smooth way. They make it available, so as I say, we get a function that when called with parens, returns out my next element. Run it again, gives me the next element. Run it again, gives me the next. In other words, the function attached and bundled on it somehow in the background must be our underlying collection of data. Plus also, we must somehow hold on to the information of which element am I currently at, so that we don't give me out the same element each time, but give me out instead the next element. But we know that when a function runs, it never remembers its previous running. Its local memory gets reset every time, right? It's empty, it's filled. So how the hell am I going to have my function both be able to be run, give me the next element, but also therefore have underlying in it, somehow bundled on it, my underlying array of data that it's grabbing the next element from one by one.
In a
and bundled
closure.
on it the sort of tracking variable that's tracking which element have I already given out, so I know which one to give out next. How am I going to bundle that all up? Imagine that if we could create a function that stored the numbers, and each time we ran the function, it would return out our next element from numbers. No, it'd have to remember which element was next up somehow. That means between the function's invocations, runnings, it would somehow have to remember what was the last element that was passed out. But if you could do it, this would let us think about array, our list, 4, 5, 6, as a stream, a flow of data, with our function returning out the next element, and then the next element. Did everyone get this bit yet? And the next element, did I say this sometimes? This makes our code more readable, and we'll see in a minute, more functional. But it all starts with us returning a function from another function. Because all
Which
of
is,
these beautiful, elegant things
this is a very elegant thing here.
begin with us returning a function from another function. Because that's going to give our function that's returned out superpowers. My favorite feature in JavaScript
The closure,
is going to be
man.
revealed right now. But folk, also I'm going to stress to you, do not get complacent about what this code is doing. This code throws the most seasoned engineers unless we're super precise line by line. And remember that we never
Function can be returned from another function in JavaScript, which is now effectively are creating a closure. And this is something interesting here.
return to previous lines of code. We always finish a line of code, we're done with it, we store whatever was the result of the right-hand side in memory, and we move on. I'm going to start off by saying, okay.
How can we run call add to now? How can we call add to now outside of the create new function?
So, line 1, blessing, what are we doing in line 1?
Defining a function, create new function, storing it in a global memory.
Excellent. Excellent, very clear. Create new function. Right, casing. There you go, create new function, storing global memory. Next line up, Josh. So we grab the whole create new function, store it in memory. What's our next line?
Is it the declare the constant of the new function?
Spot on.
Is the
Exactly.
function, create new function?
Yeah, exactly. We are not immediately going to go and create a new function. Even though it's got another function inside, we do not go inside. That's only going to be reached if we call
If we call them,
create new function. How do I call create new function, Sean?
parentheses.
I will never go inside otherwise. In fact, if I never call create new function, that code inside of there will never be defined. It'll never be, that stuff will never be saved. The overall description of the function body is saved. Think of it almost like a kind of a string of things that would be done later on. A string of instructions to be done later on. All right. Good. We declare a new function. We've got to get this piece down. This is almost an interlude. This is us understanding what happens when I return a function for another function, in order that the hard piece to follow follows naturally. All right. New function declared.
So new
It's
function
gonna be the
declared
return
is going to
value
do.
of calling create new function. Sony, if I took the parens off the create new function, and had
This
to
is now
start
a
function,
reference
create new function,
from
would I
the
be storing a new function? Parens off the create new function, and had just const new function equals create new function. What would I be storing in new function?
Wait, what?
Sony, if I took the parens off the create new function and had just const new function equals create new function, what would I be storing in new function?
A reference.
Create new function.
Spot on.
The reference. The create new function.
Function and had just const new function equals create new function, what would I be storing in new function?
Create new function.
Spot on. The entire create new function definition. I would have
The
just
definition.
new function is another label for create new function. It wouldn't be a copy, it would just be another label for that underlying function stored in memory. Very good, Sony. But we're not doing that. Instead, we're saying go run create new function.
Can recurring he was get back, and this is the add function.
Let's do it.
So now here we are break exactly here we were creating is a new break execution context here.
Create function. And remember, it could be anything. Whatever comes out, it could be a number, an object. It could be a function in JavaScript. So let's create, oh, everybody together. When we start executing a function, we create a new
Break execution context.
Rick, we're watching. We create a new
Execution process.
That's too fast. Needs to be more measured. A new execution context. Yeah, it doesn't sound like a cult unless you do it in a sing-songy voice. That is a sign. Actually, I shouldn't make this sort of jokes. Good. I hope you all feel. You can leave at any time. No, okay, this is not funny. This is not funny. All right, good. Okay, so create new function is called. What's the first thing we do inside its memory, Michelle?
We create a new function called add2.
Excellent. There it is. Oh, I'm going to do this function inside a different color. Add2. Here it is. There it is. Okay, add2 is this function. Okay, JavaScript is literally storing the whole functionality associated with the label add2. Do we call that label? Do we call that function? Are we going to invoke that function, Abdi? Are we going to invoke? Are we going to execute add2?
In this case, are we just storing that? Because return doesn't execute that. Return is just return that.
What are we doing instead, Abdi?
We are going down to return add2.
Excellent. Return the entire
The entire definition.
whose current label is add2. But we're not returning add2. We're returning the function that has the label add2. When JavaScript sees the word return add2, it goes, add2. We're going to look in memory what I stored in that label. Oh, it's this function. Perfect. So return out that entire function definition.
You return the entire.
That is literally the words function, parens, num, curly braces, return num plus 2.
It's going to return is the
And it's
entire
returning all of that
definition
functionality, and it's
of
gonna
the
store it
function.
Where, Victor? In what global variable or global label is going to store it?
You're going to store that into new function here.
There it is under new function. It used to be called named add2, not anymore, but it is still that functionality in memory. We've just passed it out, not copied it out. It's the underlying function. We just passed it out and given it a new global label, new function. Perfect. By hitting the return statement, what happens is execution context, Victor? When we hit the return statement of an execution context. Back to a function.
Wait, what?
Perfect. By hitting the return statement, what happens is execution context, Victor? When we hit the return statement.
So we remove the execution context from the call stack, and then we evaluate is what is the next on the global execution. We evaluate the next line on the global execution context.
Statement of an execution context of a function. It goes away. In terms of our call stack, it gets popped up.
It goes away.
And all the stuff in it that's not returned out is deleted, but the function got returned out, so it ain't deleted. We gave it a new label out here, so it's not deleted. Remember, posh word for deleting stuff from memory is, also deleting stuff when we close an execution context is automatic garbage. Anything that wasn't going to be used out here is garbage.
It's garbage.
Memory collection. All right. Good. So we're back out now in the global execution context. The last line was new function is going to be the output of create function, which it is. There it is. The output was a new function called add2. Well, it was called add2 in here. Now it's just the definition of add2 in the new label. So if I want to now run, call, invoke, then that inner add2 function out here, what label do I use for it out here? New.
So new function.
And how do I run, call, invoke new function? Friends, and because if I look at the definition, now we visibly, we as developers, we're going to look back at the definition of add2. JavaScript is not doing that. It literally passed the definition out and stored it in new function. So it's going to look in new function for the definition of add2. And what does it see it needs to receive, Ben? Exactly, an argument. So let's put in, I don't know, 3. And we're going to store the result of calling new function in
the result.
Excellent.
We're going to store
so
the
we're going to create at this point a new.
You're going to store the result of the new function value on the result.
Excellent.
So it actually, because we are using parentheses, we're calling that,
What's the first thing
which
that
creates a new execution context.
The parameter
which is
called null,
excellent.
and it's assigned to the integer 3.
Yeah, and so be really clear. I know I said this already, but do not think that JavaScript, when it sees new function, is going, huh, what's new function? I better go and check the line before. Oh, it's create new functions that way. The line before will never be returned to. The line before, create an execution context, inside of which it created add to, was returned out, stored in new function, and at no point do we ever, does the new function ever care about create function again. It's only
No,
care about create function in the sense of, I don't yet know what to store in me, so I'm undefined, while I go and run create function, get an actual value, this function, and store that function here. Never think that it's like, new function is a command to go and run create function.
No, in fact, it's just.
It isn't. It's whatever at that moment you got out of create function, and that's over. Never think that it's like new function is a command to go and run create function. It isn't. It's whatever at that moment you got out of create function, and that's over. So it's the add to functionality. So when we call new function line below, it is just interested in the add to functionality.
Exactly. So this new function is just only is the reference of the function itself. What is returning from the create new function, and that's it, and that's over.
It never goes back into create function. Seasoned engineers get muddled about that. Do not let yourself get muddled. If we don't get that clear, all the iterator stuff doesn't follow. Okay. So yeah, we can now run new function. We visually, that's what I'm going to say, visually, we have to look back in to see what add to's definition is. I wish we didn't. I wish we could almost literally put it out and inspect what new function is, and we'd see that functionality. That's what we're looking at. And you're right, it says num is a parameter and set to 3, where we are then going to return out 3 plus 2, return out the 5 into what global variable, Paul?
Result.
Into result. Excellent. There it is.
So now our result is that.
So thumbs in a second on. I create a function called create new function. I then create a placeholder new function that was going to be whatever came out the bottom of running create new function. So thumbs in a second on. I create a function called create new function. I then create a placeholder new function that was going to be whatever came out the bottom of running create new function.
And then you create a placeholder to whatever we call.
Well, what came out the bottom was an entire function definition, add to. Turned out. I now use the new global label new function for that functionality, add to, formerly known as add to run it, pass in 3, add 2 to it, get out 5 and store it in the global constant results. Everyone's thumbs, you lost me. I'm totally clear. I have a clarification. Your clarification might just be, why the hell did we do this? Everybody's thumbs out?
Yeah, exactly. Why the hell are we doing this?
We now have a situation here where we create a little function inside another function, returned it out into a new global label, and then use a new global label for that functionality. For what possible reason? Why did I not define add to globally? Who already knows the answer?
Because we're going to pollute. We don't want to pollute is the global. Okay. The reason of doing this is because we don't want to pollute is the global space. We don't want to pollute is the global. Yeah, the global variable.
Right. So I love the big reveals. I love the big reveals. Oh, I love the big reveals. It's going to turn out when we return a function from another function, we get so much more than just the function.
Exactly.
We're going to get a ton.
Yeah, but the whole point of this is to not polluting is the global space. Is the global. Not polluting is the global scope, okay, and abstract that into a function. That this function will contain is all of this reference, all of this functionality and data encapsulated, and also we're going to now be able to store this data that we define inside of our functions in a persist way, thanks to closures.
Of, well, a single profound bonus. And that's going to be critical for us to build out our own functions that when we call them, give us our next element from our flow of data. I don't like calling them iterators, what a strange name. But instead give us our next element from our flow of data. Let's see it here. So we want to create a function. We want to create a function that has the ability to return our next element from a list of data, 4, 5, 6 for example, but then also bundled on that function, it must have the underlying data to grab from, right? Otherwise, where's it getting data from? And it must have the ability to track which element it was on before, so that when we run that function again, it doesn't give us the old element, the previous element. How the hell is it going to do that? Because functions, when they're called, do not remember their prior invocation. They do not remember data that was created in their prior running. The local execution context, we run this function again, brand new function, add to created. There's no memory of previous running.
Exactly. It doesn't remember is a function run, but it's remember is the data.
We shall see. Well, that's what we've got to try and do. We're going to start with calling this create function.
Now you're creating yourself.
an
close
inner
in there.
function into return next element, and then we're going to hopefully be able to get our first element. Who knows how? We shall see. All right. We're going to walk through this very, very precisely because this is pretty much our only code on this whole section. But it's very important code, and honestly can be considered quite hard for folk especially who've not seen hard parts before. For folk who have, there might be a section that you remember that this is time to remind you of, involving something called a backpack. All right, good. Line
Exactly.
1. I would like to call this instead create flow, because it's kind of creating the flow. We'll call it create function here. Create function. So, what are we doing in line 1?
And anytime you
We're
run that function, you're gonna get the next element, the next element, the next element, the next element.
Excellent. Thank you, Victor. Next line, James.
You're creating a new constant called return next element.
Excellent. Do we know what it's going to be yet? What's going to be stored there yet? So it's going to default in JavaScript 2? Undefined. Excellent. So here we go. Try and get my board positioning right here. So return next element is going to be the output of calling create function, where we're passing the array 4, 5, 6 to it. We're going to create what's for a new execution context. Excellent one.
So that'll be all for this video. Take care. Bye bye.